Hello YouTube, this is Umozo3. In the previous video, we started talking about two-dimensional arrays again, right? This is something we've seen a couple times in previous videos, but basically we took a look at what if we had like a numerical matrix, like a two-dimensional array of ints or doubles, or potentially strings that we wanted to concatenate together, right? That's another use of like the plus sign operator in Java. But anyway, what we can do is we can take another look at this matrix function and review some of the things we talked about in the previous video. So I still have the console output up. I literally started filming that video about 23 minutes ago, and the length of the video is 20 minutes. But anyway, we talked about how we could print the sum of two matrices. So we create two-dimensional arrays of ints, right? And we call them matrix 1 and matrix 2. And we said that a two-dimensional array is just a one-dimensional array of one-dimensional arrays. It's just an array where each of the elements are arrays, right? And so we say print the sum of these two matrices, and it's just going ahead and add the corresponding index positions together, right? So 5 plus 7 is 12, 3 plus 1 is 4, 8 plus 3 is 11, 9 plus 15 is 24, 0 plus 4 is 4. 4 plus 2 is 6, right? And then we can also do the same thing for example.print difference. So one of the things we were looking at in the previous video, I think I didn't really explain it too long, but I guess we could talk a little bit more about it in this video, is if you pass in two-dimensional arrays and you call the print difference method, what this does, it doesn't return anything, it's a void method, but basically it's going to end up calling the print sum method. So it's going to end up adding two-dimensional matrices together. But with the second matrix, we're going to negate each of the elements, right? So what does it mean to do A minus B, like 5 minus 7 in math, for example? Well, that's the same thing as 5 plus negative 7. It's just A plus negative B. So if you go ahead and negate all of the elements in this two-dimensional array using this nested for loop, then you could just say print sum of A comma B, right? And that's what we talked about in the previous video, where we did it in the context of a try-catch block, where if these two arrays coming in don't have the same size, they don't have the same number of rows and the same number of columns, then it's not going to work out, and we would have this array index out of bounds exception. But otherwise, we're just going to use two nested for loops and say sum matrix of wx equals A of wx plus B of wx, right? And then system.out.println of arrays.toString of sum matrix of w, right? But that's basically the algorithm for it, right? That's essentially how we get it to work. But we're going to go back to the matrix function. And so if we say system.out.println of difference of these two matrices, it would basically just negate the elements. So what's 5 plus negative 7? It's negative 2. What's 3 plus negative 1? It's positive 2. What's 8 plus negative 3? It's positive 5. And it goes ahead and does that for each of the 6 elements, right? Because 3 rows times 2 columns will be 6 elements in the difference matrix, right? And the subtraction matrix, because the subtraction matrix has to be the same size as the two matrices coming into it, right? And then so in the previous video, we sort of ran out of time to talk about this transpose. So what the transpose method does is it basically flips the rows and columns, right? So if you have like 1, 2, 4, 3, now we're going to have like 1, 3, 2, 4. So it flips the rows and columns, and hopefully you can visualize that in your head. But we would say int result, and it's going to be a two-dimensional array, equals new int of array of 0.length, array.length. So I don't know if you can observe this, but here we're basically flipping the lengths, right? Because here we're going to say that the number of columns in the result is going to be equal to the number of rows in the array coming in, and the number of rows in the result is going to be equal to the number of columns in the array coming in. And then we're going to say int b, so we're just going to declare an int b. And then we're going to say for int a equals 0, a is less than result.length, a plus equals 1, b equals 0. While b is less than result of 0.length, result of a b equals array of ba, b plus equals 1. So you can use a while loop or a for loop, and hopefully you're comfortable going back and forth between the two. But this would basically just go ahead and assign an element at a current row and column of array to the column and row of transpose. So it would just flip the rows and columns. It's just basically inverting the two index positions. If you're at 1, 3, you're going to go to 3, 1. So hopefully that's clear to you, but that's what the transpose method would do. And in the print sum and print difference static methods, those were void methods that went ahead and did the printing for us. But here, this just returns a two-dimensional array. So we would have to go ahead and end up printing the transpose, right? Like the transpose method itself doesn't do the printing. It just returns the two-dimensional array that we can then print. So we could say int matrix 3 equals transpose of matrix 2. For each of the one-dimensional int arrays matrix 4 in matrix 3, system.out.println of arrays.toString of matrix 4. And so that's what you see on the console, right? And so we get 7, 15, 1, 4, 3, 2. So it went ahead and flipped the rows and columns of matrix 2 because that's what we called transpose on. And then if we say system.out.println of create a 2x2 matrix and determine its inverse. So I guess we're kind of running out of time to talk about this. Is kind of going more into linear algebra, but you could have a two-dimensional array, and if each of your one-dimensional arrays is a one-dimensional array with 2 ints in it. So you have like 7, 9, there's 7, 9 in one of the arrays, then 5 and -2 in the other array. But we can come up with something called a determinant. So this would be array of 0, 0 times array of 1, 1 minus array of 0, 1 times array of 1, 0. So I think this is kind of going to be out of the scope of these videos, but what you can go ahead and study on your own is thinking about an inverse of a matrix, right? So in linear algebra and mathematics, we can think about taking the inverse of a matrix. And the way that you would do it is you would basically go ahead and reverse the elements at index positions, 0, 0, and 1, 1. So we're going to say result of 0, 0 equals array of 1, 1 over this value that we call the determinant. And so the determinant of a matrix is array of 0, 0 times array of 1, 1 minus array of 0, 1 times array of 1, 0, right? And so anyway, I think we're probably just going to move on and not talk too much about this. But anyway, I can go ahead and show you what the inverse of a matrix would be. And so if you're not familiar with this, this is kind of a high school or college level math topic. And so if you're not familiar with this, it really doesn't hinder your understanding or appreciation of Java programming to skip this topic, right? But you could go ahead and create a 2x2 matrix and determine its inverse. So we can just go ahead and say int matrix 5, and you could say print inverse of matrix 5. And so this would be like the inverse. So you would have 0 and then 1.0, and then on the next row you would have 0.5 and then -1.0. So hopefully that's clear to you. But I think that's a little bit beyond the scope of this video and of this curriculum. That's a little bit more of a math topic than a computer programming topic. What we're going to do in this video is we're going to basically be talking about vectors, okay? And so there's another data structure in Java that you want to be familiar with, and it's called vectors. And so what we're going to do, since we have a pretty good deal of time here, is we're going to go to blackle.com and we're going to study vectors. So you're going to go to Vector Java API. And so sometimes if you've ever coded in C++, for example, sometimes engineers in C++ will talk about vectors. And basically what you have to understand is it implements a growable array of objects. Like an array, it contains components that can be accessed using an integer index, okay? However, the size of a vector can grow or shrink as needed to accommodate adding or removing items after the vector has been created. So this sounds a hell of a lot like an ArrayList, and indeed it's almost the exact same thing. And if you look at the functionality and the geometry for it is really, really similar. And there's one subtle difference in basically the synchronization or the way that the vector is processed that actually makes an ArrayList the preferred data type. Okay, so if you think about, well, why is there a vector and an ArrayList if they're so damn similar? The reason is that an ArrayList is actually preferred. So there's this little comment here in the API. And so it says, unlike the new collection implementations, vector is synchronized. So if a thread-safe implementation is not needed, it is recommended to use an ArrayList in place of vector, right? And then you could click on this hyperlink and go way back to lessons like 27 and 28 when we first learned about ArrayLists. But vectors are very similar, and so we're just going to talk about them in this video. And they have a lot of the same methods as ArrayLists do, but the point is that it's really not the best etiquette to use vectors, and that's sort of why I wanted to hold it off to the end. In fact, I didn't really know too much about vectors until after I'd started recording this collection of YouTube videos. But anyway, we're going to go ahead and study this, and you can see sort of some of the hierarchies here, right? So remember when we were talking about inheritance and subclasses, right? We had doctor and student. Each of them were subclasses of person, right? And then I think we also had an interface or an abstract class called occupation. And then like waiter was one of the concrete subclasses of that interface. And then we also had like cool waiter was then in and of itself, in turn, a subclass of waiter. But anyway, vector is a subclass of abstract list, which is a subclass of abstract collection, which is a subclass of objects. And one of the things you might remember from previous videos is that object is a superclass of every class. Object is the root of the class hierarchy, and that's one of the reasons why it's so important to define a toString method, right? It's because otherwise it's going to take object's toString method, which is a hexadecimal representation of the hash code of the object, which is not as helpful as saying something like Kimberly is 22 years old if you created an instance of the person class with a name of Kimberly and an age of 22. But anyway, this is the hierarchy, so it's obviously a type of object, but it's a vector, right? And it's it's a type of abstract list. And I think ArrayList also falls underneath abstract list or some type of similar class hierarchy. But we're going to go ahead and create a vector and learn about some of the different methods that we have available. So we have clear, contains, get, right? So you could get an element at a particular index position, just like you could with arrays or linked lists, but you could say vector.getOf2, and that would return the element at index position 2. You could say vector.indexOf water bottle, right? And so if you were talking about a vector that held string objects in it, then you could return the index position of the first occurrence of the string water bottle within your vector. And then we could also see if a vector is empty, so that would just return true if the size of the vector is 0, right? If it's either been cleared or if no elements have ever been added to it, right? And then we could also remove an element in a vector either by index position or by passing in that particular object, right? And then we can also set an element in a vector at a particular index position. And then we could also have a size of a vector, how many elements are currently in the vector, right? But all of these methods should be pretty familiar to you, right? Also add, right? How do you add an element either to the end of the vector or to a particular index position within the vector, which would have the effect of shifting all subsequent elements one index position to the right. But hopefully these methods are already clear to you, right? And so you're just going to say import java.util.Vector. And I'm just going to show you some of the functionality that we have available. So we have a vector function. And off the bat, I'm just going to go ahead and run the vector function. So it's just a static method, so you can just run it from this IDE, right? And so what we're going to do is pull up the code. So we're going to create a vector of type string, and we're going to call it pizza. And we're going to say vector of type string pizza equals new vector of type string. And we're going to say pizza.add of dough, pizza.add of sauce, pizza.add of cheese, pizza.add of ham, pizza.add of pine concatenated with apple, right? That's one of my favorite pizza toppings, is like Hawaiian ham and pineapple is the way to go. And yeah, that's you're a cool person if you like pineapple on your pizza. But anyway, we're going to say system.out.println of pizza.size. And so that's going to go ahead and print 5 on the console because there's 5 elements that we just added to the vector. And then if we say system.out.println of pizza.getOf3.length, so remember pizza.getOf3 would be a string that's referencing one of the elements in the vector. And so there are 3 elements in the word ham, because ham is the element at index position 3. And then if you say system.out.println of pizza.contains of pepperoni, that would be false because pepperoni has not been added to this vector without being removed, right? And then if you say system.out.println of shuffling, you could say collections.shuffle of pizza. So just like you can shuffle an array list or linked list, you can also shuffle a vector. And then you could say for each of the strings item in the pizza vector, system.out.println of item.toUpperCase. And so after shuffling it, we just randomly got sauce, dough, ham, pineapple, and cheese. And that's certainly not the order that we initially added the elements in. And then we could say pizza.add of bacon, pizza.add of pepper, right? And then we could say system.out.println of just added bacon and pepper. Let's sort according to strings compare to methods. So like we've been talking about over and over again, any class that implements comparable and defines a compare to method can be sorted. And so you say collections.sort of pizza, right? And so presumably that would do it alphabetically, right? So C, D, H, P, S, right? And then you see a lowercase b and a lowercase p, right? So this would be like in ascending order in terms of the character codes, right? We sort of saw a little bit of that in the previous video. And then we say for int p equals 0, true, p plus equals 1. So it's this loop is going to run forever, right? It's going to go p equals 0, 1, 2, 3, 4, 5, 6, 7 up to infinity unless there's an opportunity to break out of the loop. So we're going to say if p is less than 0, continue. But like in this context, hopefully you can see if we start at 0 and just increment by 1 every time, this Boolean is never going to be 0. So we're never going to skip the rest of the loop, right? That's what continue would do. So we're going to go ahead and go down here. If p equals pizza.size, well, that's not going to happen until p makes it to pizza.size, like presumably until we're done iterating through the elements in the vector. And so we're going to say system.out.println of pizza.get of p until p becomes equal to pizza.size. So we're just going to go ahead and print the elements after we added bacon and pepper. And I guess that's what already happened here. And then for any collection, methods for add and remove might also return something. So what if we say system.out.println of pizza.add of sausage? So what does that print on the console? It prints true. So in a vector, an add is an instance method that returns a Boolean. And so if you don't believe me on that, one of the things that we could do is we could go ahead and study the API, right? And so what we could do is we could go ahead and look at this method. And so if you call add, we usually just call it, we could say just vector.add of x would add element x to the end of the vector. But here, look, it returns a Boolean, that's the return type. And so it usually just returns true. And so it would just return true. Like if you ever want a true Boolean, just add add an element to a vector and just set the variable equal to that, right? But then that would just be true. And so that would just be pizza.add of sausage. And so not only would it return true, but it would obviously go ahead and add sausage to the vector as well. And then if you could say system.out.println of pizza.remove of 0, right? And so one of the things we said is that if you call remove, not only does that remove the element at index position 0, but it also goes ahead and returns that element that was occupying index position 0. So it removes the element, but it also returns it, right? So it returns the element that was removed. So that's according to the API. And that's true for ArrayLists and linked lists and also like stacks. Remember with pop, that would also remove the element from the top of the stack, right? But anyway, pizza.remove of 0 returns the element that's being removed. And so that would remove cheese, right? Because that was the first element in the vector after we sorted it. And then what if you said system.out.println of remove of pizza.remove of dough? So that would return true because we could remove dough from the vector. But if you say system.out.println of pizza.remove of sauce, well, it looks like sauce was added to the vector, but this remove method is case sensitive, right? So this sauce here is in all capital letters, right? And if you see this sauce in all capital letters on the console, that's because we were just printing dot to uppercase, right? But the elements in the vector are mostly uppercase with the exception of the first letter, or mostly lowercase with the exception of the first letter. So we can't remove sauce from the vector because sauce is not one of the elements in the vector, and that's why the method returns false, right? So it returns true if the element was removed from the vector and false if it was not. And the only way it would not be removed from the vector is if it did not already exist in the vector. What we're going to do now is talk about instance of. This is something that we brought up in a previous video, but I want to review it for about 2 minutes. So q of type string myQ equals new linked list, right? So this is the way that we talked about for creating a queue. This is the method that we talked about for doing that. And so we're going to add 3 elements to the queue, right? These are going to come in order, like people in a supermarket, right? The basketball is going to line up first in the supermarket. So myQ.add of basketball, myQ.add of hockey, myQ.add of tennis. And then we're going to say system.out.println of myQ.poll, right? So hopefully that's going to give us basketball because we said that Q is a first in, first out data structure, right? So we're just going to go ahead and run this. So I want to show you the instance function. And so it's going to print basketball, right? Because that is going to be the poll, myQ.poll, but then it removes basketball from the queue. And then if we say system.out.println of myQ instance of linked list, right? So technically a queue would be thought of as a type of linked list. So that returns true, right? This one returns true. But is it a instance of ArrayList? No, a queue is not a type of ArrayList, so this returns false. Is myQ an instance of queue? Well, presumably yes, it is. Is it an instance of hash map? No, it's not. System.out.println of myQ instance of stack, that would be false as well, right? MyQ instance of object, true, right? So every object is an instance of object, right? Because we said object is the root of the class hierarchy, but the point is that you can sort of call this keyword or this important word, it's kind of like a function or a method, but not really, because there's not parentheses, right? But you just say system.out.println if my q instance of hash set would be false. System.out.println if my q instance of vector would be false. System.out.println if my q.peak instance of string, right? So this would be one of the elements in the queue, and indeed that would be a string, an instance of string, but it would also be an instance of object because string is a subclass of object. So hopefully that's clear to you and interesting to you, and we'll talk more about that in the next video. From umils03, thanks for watching, and please subscribe.